Hello friends, today we'll be discussing about properties of steam, which is first chapter in basic mechanical engineering. Now I'll be starting with the temperature versus enthalpy graph. Okay, now let us consider this point A, point B, point C, and point D. Now first I'll explain about the temperature at all these points. As you can see, the temperature at point B and point C is same, and this is called saturation temperature. And the temperature at point D is called superheated temperature. And this saturation temperature completely depends upon the pressure of water at which it is present, but the superheated temperature is set by the user on the requirement or based on requirement. Okay, now the amount of heat that is given till point B is known as HF. This is sensible heat of water. The amount of heat given till the point where the water does not change its phase. That means any energy given above this point B, that is more than HF, that will lead to change in phase of water from liquid to gaseous state. And the energy given till point C is called HFG. This is latent heat of water. That means this is an amount of energy that is given to the water to completely convert it into the steam. And now the amount of heat that is given till point D is called amount of superheat. I'll write it as AOSH. This is the amount of energy we give from saturation temperature till superheated temperature, that is still the requirement of user. Okay, now I'll be starting with the formula discussed. Formula used. The first one is dryness fraction. The symbol used is X. Okay, this dryness fraction has importance only between point B and point C, because this tells us that how much dry steam is present in the overall steam. So the formula is also mass of dry steam divided by total mass of the mixture, that is water and steam together. This basically tells us how much dry steam is present in the mixture of both, in the mixture of water and steam between points B and C, because anywhere between point A and B it's completely water, and anywhere at any point after C it's completely steam. So this is the symbolic representation. I'm going to the next one. Enthalpy of unsaturated and saturated. I'll be explaining both of them together. Water. Okay. Okay, now this point B is where the water is saturated. As I have explained, above this point, any energy given to water will change its phase. So from what we know, if this point is saturated water, and so any point between A and B, the water is unsaturated. It has not yet taken up all the amount of energy required yet. Let us take this point to be E. Now to calculate the enthalpy at point E, we should multiply mass into specific heat of water into temperature at point E minus 0. That is because temperature at point A is 0 Kelvin. Specific heat of water here is 4.187. This specific heat of water will change after point C, because specific heat actually means the amount of heat that should be given to the water to raise its temperature by 1 degree. Because it will be completely steam after point C, the specific heat will be little less. And the unit of specific heat is kilojoules per kg Kelvin. We can verify this if we substitute it here in the enthalpy formula. Mass is kg multiplied by kilojoule per kg Kelvin multiplied by temperature unit, that is Kelvin. We can see everything is cancelled and we are left with kilojoule, which is the unit of enthalpy. Okay, now going on to the next one. Enthalpy of wet steam. Okay, let us take a point F between B and C. As we know, here it's not completely steam or it's not completely water, it's a mixture of both water and steam. So how do we find the enthalpy at this point F? Here we can make use of dryness fraction, and for that, as we have already given all this temperature for the water, we can just we'll take this point as G instead. So it can be written as not even G, so the different point. Let us take H. J. Let us take this point as Hj. Here the total energy will be equal to Hf plus, we should multiply it with dryness fraction and with the entire energy required to convert all the water into the steam. I have multiplied here it with dryness fraction because only some part of all the water has been converted into steam. That means not all the water is converted into steam. So that's why if we multiply the dryness fraction with HFG, it gives us the exact amount of energy that has been used to convert the steam into water till this point. And next, this enthalpy of dry steam. This is nothing but the total enthalpy present at this point, which is nothing but HF plus HFG. It is at that point because point C is where the entire water is converted into steam and there is no water left. The enthalpy of superheated steam. I wrote a graph once again. Okay, now this is the point B. This is HF, HFG, and now we'll have to calculate this energy given till point D. Okay, before that I would like to discuss about degree of superheat. Now as we know, this is superheated temperature and this is saturation temperature, and degree of superheat is nothing but temperature difference between superheated temperature and saturation temperature. Okay, now enthalpy at point D is equals to HF plus HFG plus mass into specific heat at superheated temperature multiplied by difference between superheated temperature and saturation temperature. Okay, now here degree specific heat of water is not 4.187, it is 2.25. There is decrease from 4.187. This is because it is easier to increase the heat of steam by 1 degree than that of water. That's why this is lesser. This will be the last formula we are discussing today, and it is boiler efficiency. Uh, from here, we can see Q is the quantity of steam that is generated for every that is generated in kgs for every hour, and as we can see, Hs is enthalpy of final steam that is generated, and Hw is enthalpy of feed water. Both of them are in kilojoules per kg, and this is mass of fuel and gross calorific value of the fuel. Calorific value is amount of energy that is produced by fuel per kg. This is also in kilojoules per kg. If you see for units, Q is in kilograms per hour multiplied by this energy is in kilojoules per kg. Mass of calorific value. Okay, wait. This is not just mass of mass of the entire fuel. This is the mass of fuel that is being used specifically per an hour. So this is again kilograms per hour, and gross calorific value is again kilojoules per kg. As we can see, all of them get cancelled, and we are left with one. Therefore, we can say efficiency is of no unit. It has no units. Thank you.